Я надеюсь, что все поняли, что у нас есть опечатка небольшая в нашем флайере, который говорит о том, что сейчас у нас доклады и очень крутые как раз в каждом из потоке. А вот в нашем потоке супер крутой спикер. Я думаю, что этот человек расскажет, как минимум мне очень важную для меня информацию, благодаря которой я как минимум приехала на эту конференцию. Ну что, встречаем крутого спикера, независимого консультанта по Amazon Web сервису. Его имя Остап Сорока. Аплодисменты нашему спикеру.
Hello, I'll be speaking today in English because it's better to speak in English about technical terms. My topic today is called AWS architecture and the human body. It sounds controversial because it is. I'll be talking about 3 cloud architecture patterns and how they relate to human body, human physiology, as to be precise. I will describe 3 patterns. First one is auto-scaling, second one is messaging, and third one is auto-healing. Today we're gonna learn few Latin terms. We're gonna know why your servers sometimes sweat, why it's better to send messages than to make calls, and how many health checks your body does every day. Few words about me. I'm coding for 12 years already. I hold AWS Certified Solution Architect Professional certification. And the idea of this topic came to me when I first dived into the AWS services. I love evolution and biology. And while I was learning AWS, I thought it could not be possible to have the same direct analogies between the cloud architecture and the human body. So I hold this idea for a few years, and here you go. I have a topic about it. So we start with the question for the audience. Who believes in evolution? Nice! My job is easier today. So, according to common knowledge, the life on Earth was born around 4 billion years ago. Then it comes ice ages, dinosaurs, they die, and around 3 million years ago, we develop as humans. Homo sapiens is being built. Around 100,000 years ago, we migrate from Africa to all continents, and we have different races. The body that we currently live in is the pinnacle of evolution, because there is no such complex and sophisticated living form living anywhere on the planet. This body was built in a constant process of natural selection. Nature selects what is best and leaves aside what is not perfect. And the 3 patterns that I'm going to describe today, I believe they were not invented by any programmer or any cloud architect. I believe they were invented by nature, and they were just applied to the cloud architecture because they were so good and working so great. So to help me explain my point, I'll introduce you to the fake startup company called Suitup. This company is building the perfectly tailored business suits for the top-level business executives. You're working there as an engineer. You're in control of the IT. Your main focus is that you are doing the 3D scans of a human body, and you have the perfect measurements up to a millimeter of your client's body. Then you tailor perfectly tailored suit, and you sell it to the customers. Everybody is happy. Currently, you have a prototype, and your architecture looks like following. Nothing too complex. You have some front end, some database, and somewhere on the back end, you have a 3D rendering server that is doing the heavy lifting of rendering of your scans into actual 3D models of your client's body. You, as a DevOps engineer, you build continuous integration, continuous delivery, Everything works as expected. You are approaching the release date. You're having the first beta testers. Investors are pushing. And there is a small dilemma in your mind. This backend server that is doing the 3D rendering is very heavy, computationally heavy. It is doing actual CPU-intensive workloads, and you actually don't know what will be the load on your server, and you don't know what server capacity to provision. Your dilemma is following. Either you under-provision, and you guarantee to have less performance when you need to, or you over-provision and you spend a lot more money than you had to do. You have not resolved this dilemma. Months goes by, you're approaching the release date, but you decide to lift your team's morale. You plan some team building and you go out for skiing. You plan for a skiing trip with your guys. Who have been to skis ever? Okay, who have been to sauna after skis? Who ever been to sauna? Okay. So imagine long day after skis. You are physically exhausted, your body hurts, you are tired, and you move into a sauna. You feel the warmth, you feel the smell of the wood, the comfort, your body starts to relax. After a few minutes, something happens to your body. What happens to you when you are in a sauna? Anyone? Okay, sweat. Anything else? Okay, blood. Perfect. Your heart starts pumping blood. You start sweating all over your skin. Turns out that this process is natural, and it comes from the following system. All over your skin, there are tiny receptors that detect the temperature. In your brain, there is an area called hypothalamus that constantly monitors these sensors on your skin and decides, is it too hot or is it too cold? Depending on the temperature and your internal temperature, which is also detecting, it acts and it decides to do something with other of your internal organs, like your body, like your heart. The reaction that you have in sauna is following. The receptors on your skin say something to the brain, saying, we are out of normal temperature. Brain decides it's too hot and he should do something about it. Brain sends signals to your heart. Heart starts pumping blood more frequently. It also sends signals to your blood vessels under your skin. So more blood is under your skin surface and not in your internal organs. It also sends signal to the skin to start sweating more. As a result of a threefold process, the sweat starts evaporating from the skin, it cools off the skin, thus it cools off the blood in the blood vessels under the skin, thus it cools off your body. Great, isn't it? This process works constantly. Whatever you are tired or you're freshly rested, whatever you're drunk, intoxicated, in good mood, in bad mood, on your wedding day or worst day of your life. It just works. Mentioned here that you haven't had any conscious thought in your head that it's time to start sweating or pumping blood. You don't have this thought at all. It all happens subconsciously and automatically. Brilliant. Another important fact is that this temperature is not constant. It has some corridor, sort of say. It not go above or below some threshold. This mechanism is called homeostasis, and it's defined as a system of metrics that define your internal state and the mechanism to keep this state. Why I am telling you that? So imagine you sit in a sauna and you sweat heavily. And imagine that while you are sweating, some bright idea comes to your mind. What if your backend server that is doing the heavy CPU-related lifting, what if it could automatically be more powerful when there is heavy incoming load and less powerful when there's no incoming load. What if you could somehow track and measure what is the traffic on your site, and depending on the traffic, either provision more servers or release redundant servers? What would you do in this situation? Anyone? There's an answer here. Okay, you come back to your office, you start Googling it, and there's a term called autoscaling. Autoscaling is an actual homeostasis in AWS. It does actually what it says in its name. It scales automatically depending on your load. There is a notion of autoscaling group. Here it's defined in terms of last EC2 instances, but autoscaling group is basically a group of instances that are focused of individual single purpose, and they can be increased or decreased depending on some parameter. It's not automatically, magically happening. You have to do some magic on your own. Idea is that you have something that is called CloudWatch. CloudWatch is also doing actually what it says it's doing. It monitors and watches your cloud infrastructure. As in case with the body temperature, you can monitor something on your server that you're interested in. For example, you can monitor for the CPU load. You can trigger some alarm when CPU on your servers go above some threshold. You can trigger a thing called scaling policy. Scaling policy is the definition of what you are doing when this threshold is being crossed. In our case, we can just increase the numbers of servers in this autoscaling group. After the scaling policy is executed, new instance is created and added to this autoscaling group. And you have the CPU load on the whole group being dropped because there are more servers taking up the load, so average load drops below some threshold. If I put it side by side with the human body, I cannot stand to see the analogy. There is some normal state in your body and in your autoscaling group. There is some change or some action triggering changes. So we have either CloudWatch alarm or the sensors on your skin. And there is something that is deciding what to do about it. Something in our case of human body is this hypothalamus in your brain. In terms of AWS, it is scaling policy. Action is taking either by pumping blood and sweating or adding more servers to the autoscaling group. And here you are back in the first stage of the loop. Everything is being auto-corrected and back to normal. When you figure this out, you change your architecture. Now your architecture looks like that. You don't have one single powerful server. You have autoscaling group with multiple servers. There can be 2, 3, 20, whatever you need. But you have a next problem. You don't know what server should you call. Previously, you had one server, and you had a clear IP address, and you were doing some direct remote procedure call. You had some API, it returned you some results. Now you have multiple servers. You don't know what IP to call. How do you solve that? Okay. Well, let's say that you start Googling it, and a few minutes pass by, but you are tired and you feel hungry. You decide to make a break. You go outside to some coffee shop, you order yourself a nice big cup of latte with 2 spoons of sugar, and you have a nice donut with some fat and sugar on top of it. You eat it, you feel the taste of coffee, you feel relaxed and good. Tastes good. But while you are relaxing after coffee, your body is working ferociously underneath, undercover. So This is the graph of your blood sugar level. Blood sugar level is actually an important indicator of internal state of the body. It should be in certain threshold, and your body likes it that way, and it doesn't like when it goes up or down. So this is the daily average human blood sugar level. And after you have eaten something very sweet, your blood sugar level goes up tremendously because the sugar is very easy to digest, so it goes directly from your digestive system into your blood. Any drastic change in the level is bad, so your body decides, I should do something about it. The system built in your body is built in the following way. The blood sugar level is being mitigated by the hormone called insulin. And please bear with me, it will be nice. Insulin is being produced where? Anyone? Yes. Beer to that gentleman. There's an internal organ called pancreas, in Ukrainian pishlunкова залоза. So pancreas, everything it does, it detects for the blood sugar level, and depending on the blood sugar level, it starts producing insulin and dropping it into the blood. Nice. Another end of the chain, there are three groups of organs. One is liver, a second is your muscles, and then there's a fat tissue. If there is a lot of insulin in your blood, your liver starts to converting sugar into glycogen. Your muscles start to intake glucose from the bloodstreams internally, and it also happens with your fat tissue. It starts to take out the blood and store it. Please note important thing. Those two organs, pancreas and liver, literally touch each other, then sit one on top of another. They are in a very close proximity to one another. Yet, they don't talk directly to one another. They talk via the hormone called insulin, which is dropped to the messaging queue called the bloodstream. Also, there is not only one recipient of this hormone. There are three, maybe more. I'm not that good in physiology. So you see the four organs are involved in this process of lowering down your blood sugar level, and they are not literally blocked. They are not waiting synchronously for other organ to come back and say, yeah, I handle it. They work as a decoupled system. You know well what is decoupled system. Decoupled system is the system of semi-independent components that talk via some form of messaging, and every individual component is doing any job only when it needs to do it, and the actual work is being triggered by some form of message. The benefit of this form of organization is that nobody is being blocked. Everybody can work concurrently, and there is an asynchronicity between those components. If we look into AWS architecture, we have direct analogy. This direct analogy is called simple queuing service. You have producers that produce some messages, and you have consumers on the other end of the queue. The queue is asynchronous, meaning someone can read from it asynchronously, while someone is writing to it asynchronously. It is non-blocking, and it can act as a buffer. So when there is no one reading from it, there still can be writes to it from the other end. So for example, it's good when there are no consumers for your 3D rendering job available, but you are putting the 3D rendering jobs to be processed later. There is an important thing about CloudWatch metrics. You can literally watch the length of a queue, and depending on this length of a queue, you can do something. In our case, you decide that it's a good idea to scale the number of 3D rendering servers when the queue is being growing uncontrollably or growing a lot. Great success! Now you have auto-scaling group detached from the front end via the simple queuing service, and you have it being independent, decoupled. What is the great success? You start your beta testing. You have your first customers. You have a good feedback. You are about to go live. Turns out that your programmers, brilliant people, but they have some bug in this 3D rendering server. It sometimes hangs completely. It just goes 100% CPU, and you cannot do anything about it. You ask them, guys, please do something about it. But they promised it 2 weeks ago. They promised to optimize it, cover it with unit tests, and take out the Christmas tree finally. But they haven't done anything about it. So you have something that is called zombie in this auto-scaling group. You track it manually. You double-check every day your CPU load, and you kill manually this server just to avoid the cost, because it takes money to spin up extra server that does nothing. You jokingly say that it's like cancer. So those zombie servers spread like cancer, and they are hard to kill. Actually, cancer is the problem with your cells. Every cell has internal mechanism to destroy itself. Every human being has about 37 trillion cells internally, about. Every individual cell in your body has a mechanism to destroy itself, to commit suicide. And a lot of cells are dying right now while you are listening to me. So I have a question to you. How many cells die per day in average human body? Anyone? No, not trillions, but somewhere in between. So the Wikipedia says it's like 50 to 70 billion cells. Billion is 9 zeros. If you divide it by the total number of cells, it's like 0.16% of your total cells. They die per day. The death of a cell is not bad. You're not going to die because of that. Well, you are going to die, but I don't care. So the individual cell death of individual cell is bad for individual cell, but it's good for overall organism. If individual cell dies, it does it because of some reason. Maybe it detects that something is going wrong with the cell. Maybe someone told it to go away, and this process is very graceful. So there is a mechanism for decomposing the cell, cleaning up the mess after it, reusing the components that was left over, and it's called in medical terms apoptosis. I'm telling you designed to fail because it's literally designed by your evolution to lose some of the cells and recreate the new versions of the cells in your body. So if you remember about billions of cells being dead per day, how many servers are you ready to lose per day? Okay, the 0 is the bad answer, and everything above 0 is the good answer. The AWS mechanisms, it's a platform, and it's a platform as a service or infrastructure as a service, and everything fails all the time, as this Amazon CTO once said. So literally, hard disks fail, computers fail, networks go down, availability zones go down, everything breaks. If you want to build your system that is working and resilient, you have to expect and anticipate that something will go wrong with your servers. You should be literally waiting for it. You have to have procedures and ways to work around it. There is no way that you can explain to your boss or to your investor that we are not live because blah, blah, blah. He just don't get it. So the idea about recreating something when another instance is dead is pretty common in AWS services. It's built in literally everywhere, but it starts from the EC2 instances. So if you rent a simple plain EC2 instance, you can trigger a CloudWatch, and it will recreate you the same exact copy whenever the first instance is being not responding as healthy. You can do the same thing with the auto-scaling groups. Auto-scaling group will literally do it automatically. You don't have to do anything about it. There's the OpsWorks stack that can auto-heal and spin up new servers when old ones are not being marked as healthy. And it's the same mechanism with the load balancer and auto-scaling group. If load balancer marks individual server as not healthy, it's being automatically recycled and reprovisioned. I cannot stand from putting up another analogy. Analogy goes, treat them like cattle, not like pets. So in this analogy, cattle is servers that are being automatically provisioned. They are provisioned in bunches. They are identical, created from some automated scripts, provisioned, paid. There's a ways that you can lose individual server and not suffer about it. You are not emotionally attached to a cattle. Death of a single cow is not a tragedy. There are many cows dying each day, and you have a lunch with them. The pets are something that you're emotionally attached to. There are servers that have names that you manually built, that are special snowflakes, that you know some special scripts, special recipes to create, that were manually maintained in the middle of the night. If this server goes down, it's all hands aboard. You have to do something about it because nobody can work. So these are pets. Idea about this whole cloud architecture, there should be no pets at all. There should be no special snowflakes. Everything is being replaced, reprovisioned automatically, and nobody even cares about it. There are two implications because of that. Implications for your architecture. First implication is every server that you have in your system should be able to be provisioned automatically. Meaning every script, configuration, installation, recipe, it should be automated and not involving any manual labor. It should be done on a daily basis. Another implication is that you should not store any state on these servers because they can go down anytime. This is the implications for your architecture. Actually, I don't like this analogy because it involves blood and death. I like my analogy more because the cells die gracefully and there is no blood and pain. But this analogy is more common in the internet, so I have to mention it. So you have your for next iteration of your architecture. You have auto-scaling group, health checks, simple queuing servers, and you have it working automatically all day, every day. How good is that? Now I am approaching the actual topic of my talk. This is the book by Nassim Nicholas Taleb. It was released at 2012, and it's like fourth book of Taleb, and it's called Anti-Fragile. I'm a great fan of this guy. He's an ex-financial trader, but he can be named as a philosopher. He struck some note with that book. He's describing systems, organizations, organisms that actually gain from disorder. Gain from disorder. We have to digest it briefly. If something breaks under the stress, it is fragile. If I'll drop this glass to the concrete floor, it will break because it's fragile. If this glass would be from the steel, it would not break. It's robust or resilient. If this glass would be better after dropping it on the floor, it will be anti-fragile. So it's hard to get, but the idea is whatever stress you have on your system, it makes your system not worse, not makes it work slowly, but makes it better. Taleb claims that any living forms or organizations or countries or economic systems that work in the same manner, they prosper and they are viable. Anything that is rigid or fragile cannot prosper and they die. There is another principle in this book called overcompensation, and I cannot stand myself from yet another analogy. Imagine yourself being Arnold Schwarzenegger and you're a bodybuilder. You want to be Mr. Olympia. You hit the gym heavily. You lift weights. And on day one, you lift 50 kilos in deadlift. Your body treats this as a stress and works accordingly to grow the muscles to be able to withstand the stress. But your body is smart, and it does it in following manner. It not only helps you to lift 50 kilos next time, it overcompensates and says, my environment is getting crazy. I'm expecting the deadlifts of 50 kilos. I should do something about it, and I will prepare myself to lift 51 kilo next time without even you noticing. Next time when Arnold comes to the gym, he's ready to lift 51, and your body detects, oh, environment is even more harsher. I should be ready to lift 52 now. This process of overcompensation goes on and on. And it is actually the principle between yet another fancy methodologies or approaches to the architecture. One is called Anti-Fragile Software Manifesto. So in 2016, some smart group of people, based on the book of Anti-Fragile, decided to create the Anti-Fragile Software Manifesto. They say it goes above the Agile Software Manifesto, and there are 12 points there. Main, for me, are being focusing on customer, embracing any failures and errors, and having the very good team and internal team communication. They also focus on stakeholders and how do you maintain the system. For me, this whole Anti-Fragile Software Manifesto works exactly like DevOps philosophy, just working from another angle. There's also another thing called chaos engineering. So imagine when you have built your systems that are, withstanding any load, automatic, elastic, resilient, robust. What you want to do is actually play yourself as an evolution. You want to test the system in a real-world environment. And how do you do it? You deliberately make stresses to your system. For example, you turn off some availability zone in your whole system, and you watch what's happening. Will your system behave properly? Will it stop working, or it will be working in the degraded mode? You can introduce some latency between the nodes. You can switch off single node or recover single node. You are actually acting as evolution, artificial evolution for your system, and you're trying to speed up your learning. By doing deliberate harm to your system, you're trying to make it better next day and be ready to withstand any extra stresses. This nice picture here, if you Google it, you will find some great speech from the Netflix engineers, and they explain how they do it. So the Simian army is the group of tools that they developed internally, and they have a chaos monkey, a Kong monkey. Basically, they are playing around the same idea. They are deliberately turning something off to check how the system behaves. But you should Google this topic and this speech. It's awesome. So we are returning to our starting point of our journey. Evolution is a harsh and merciless lady. Everything that we see now living is a product of a natural selection. If it was fit and robust and could adapt to the environment, it remained in a gene pool and procreated and left kids, and its kids left their kids. If it was not fit and adaptable, it just died, and it was removed from the gene pool. So if you really want to make your systems working, if you want to make it robust, if you want to make it live in few years, you have to be like a creator. You have to be a god. You have to give this baby everything that it can use to withstand any stresses and any loads. So get these examples, get these patterns from all around you, and put them in to your systems to make them live and be awesome at your job. Thank you. This is it.
I'm running your software on the Spot instances on the Amazon. I mean, everything on the Spot instance.
No.
But that's like a nature of Chaos Monkey, when you can lose your hardware every time.
Well, Spot on demand or reserved is just a pricing model. It's not about that you deliberately have to run everything on the Spot instances. Well, every 120 seconds. But yeah, you're technically correct. But your main idea is to expect it and be ready to respond to it, not necessarily to deliberately put yourself every single minute into that situation. But yeah, correct question.
Sorry, Chaos Monkey, it is about kill your load balancer, not about kill your node.
Please.
Thank you. I would like to ask about overhead for message queue. If you send a lot of data to database or from database, will be huge overhead for it.
Sure, it will. It will. If you have, e-commerce site that you basically see a page, you order the product and you select where to deliver it, it's not good. But yet still, the biggest, e-commerce sites work in that manner. The Amazon.com works as a form of microservices that are not really connected, directly. But if you have something,
We have commercial application which produce huge reports, and I think it download lots of data from database and process it and out it to users. I think it will produce lots of traffic to the message queue. So for us, I think it would not be suitable.
Sure, it will not. Definitely not. Don't
Thank
do
you.
it.
Thank you.
The best example of this message queue is, for example, you have the enterprise, the big corporation company, and you have like dozens of internal systems, one for the logistics, accounting, procurement, HR, ERP, CMS, whatever acronym you have. And there are literally dozens of the system working in the whole enterprise, and you have to somehow connect them together. So the messaging is actually about connecting, components, or you can call it the systems together. So you cannot modify all the individual software in your company, but you can make a common queue that they can talk to each other through. This is the idea. Sure.
Thank you very much for your presentation. And it looks like it's like a new philosophy on build the architecture. It's quite interesting because we can take a look to the new way how we can think about new product and when it will be built. My question is that on how many platforms you have tested this approach? Because right now we focus it on AWS. It looks like AWS is ready for build this new, I don't know, dinosaur or maybe a new culture. What's about, I don't know, Google or on-premise, something like that?
Okay, thank you. I don't think this is the new way of building architecture. It's not for me. It's only an approach. Basically, this is the microservices and the decoupled applications. The new approach is that you deliberately know that something is going to fail, and you not avoid it and close your eyes about it, but you anticipate and wait for it and learn from it and make your system work better after this information or stressor.
This is why I call it new, because we always focus on build something and we believe that it will be always working, and we always in stress when something wrong or failed. For your approach, you say that be ready that something will be wrong on first step of deployment, second step, or something like that.
Yeah, but it's not me. Someone smarter said it a long time ago.
Yeah, we need to learn this, guys. Thank you. But what's about the platforms? It's only on AWS, or it can be done on another platforms?
I say it's not about AWS. The messaging queue was I don't know, in 70s or 80s. The auto scaling works in any cloud platform I'm aware of, and health checks also is common knowledge. It just everything combined together.
Okay, thank you very much.
Ostap, thank you for your speech. I like your idea to compare health systems with vision to architecture patterns. But in my mind, I cannot agree with this comparison because God is not limited at all. He is not limited by time, he is not limited by resources, and people who in real world play with architecture, they always are limited at least by money. It will be interesting to, next time, it's my feedback to you, it will be interesting to see your vision, how those patterns are affected by costs and where's trade-off. Because those patterns, you are good as long as you are not limited by resources and money. Then you can build ideal system, but you always limited.
Well, I definitely understand your point. I might not 100% agree. The one of the 13 14 principles of Amazon or AWS as a subsidiary is to be frugal. Frugal means, save every penny. It's not stated here, but I know it. Another point is that you have to have some redundancy to be actually resilient. You have 2 kidneys on each side. You have 2 pairs of eyes. You have 2 pairs of your lungs. Why? It's wasteful. Why cannot you live by only one? So idea is that there's a book by Adizes. It's about the critical chain and critical path, and he claims that there is no individual plant that can be 100% efficient. To be able to produce and be reliable, you have to have some redundancy, some underutilized resource, some spare time, some spare workers, because there is the stochastic fluctuations about when happens and what happens. You can have the average load of 50% CPU, but sometime you have 100%. If you are planning on this average 50, you will fail when it goes up to the 100. Still, if you have the cloud, first the promise of the cloud is elasticity. And this is the first pattern I described. So it scales up or down depending on your load. And this is the first pattern I described with your dilemma about the costs. So if you have the question, how much does it cost? I claim that if you put a lot of thought into it, you can pay as you go.
And also another answer, you always can set maximal size of your autoscaling group, and it limits you to money. So in that case, it will be not more than 50 instances, and you know that 50 instances will cost you at month X. Maximum. It will be maximum. But when of course, autoscaling group has minimal size, designed size, and maximal size. And maximal size, it is your maximal limit of your money. Yeah, so, okay, no autoscaling because you don't have money.
Thank you.